Hello, you Greta's and Shootez cats out there. Welcome to Chapter 6 Notes, Unit 1, What Factors Influence Climate? So here we go. Multiple things influence climate. So we have incoming solar energy, which is the sun, Earth's rotation, global patterns of air and water circulation, gases in the atmosphere, and then Earth's surface features as well, which is also called topography. So we have lots of different climates, but the first thing I want to make sure you guys understand is that weather and climate are not the same thing. Weather is short range, so this is daily things, changes in precipitation, humidity, wind speed, cloud cover. If you want to know what it is outside right now, you go to weather.com or your weather app. You don't go to climate app. Climate is more long-term. Pattern of atmospheric patterns, at least 3 decades, so 30 years to thousands of years of average weather for an area. So weather is today, climate is more long-term. We also have climate that's going to vary among Earth's regions. Obviously, the poles are cold and the climates near the equator are quite warm. And these variations are mainly due to both wind and ocean currents, which we will look at. So here are climate zones. You have our polar areas, your subarctic, and then you get to cooler temperatures and warmer temperatures and all those fun things. So feel free to look at this, pause and look at this for as long as you want. But here are the different climate zones, and you can look and see where the warmer areas are and the colder areas. So climate is influenced by both ocean currents and wind. Wind and ocean distribute the heat and precipitation fairly unevenly across the planet. There is some order to it, but it is somewhat uneven as well. So the ocean currents, you have mass movements of surface water driven by winds and shaped by landforms. And 3 big things happen to affect water circulation. Number 1, the Earth is not heated evenly by the sun. Number 2, the Earth rotates on its axis. And number 3, various properties of air, water, and land, all of which I'm going to talk about here in a second. So the Coriolis effect is one thing, and this has to do with the rotation of the Earth. And I'm going to put the link to this video in after these notes, or in with these notes, so you guys can see this, because it's a fairly decent video that explains it better than I can. But the Coriolis effect basically is the deflection of a mass as it moves over a spinning surface. So as the Earth is rotating, it's a ball, the surface near the equator is going to spin faster than regions to the north and the south. So think about if you had your arms out and we're spinning in a circle, your hands are going to be moving faster than your head would. Same with the Earth. So winds that move north or south towards the equator are going to go to the west, and those are called northeast or southwest trade winds. And winds that move away from the equator deflect to the east, which are called westerlies, because they came from the west. Easterlies are surface air that goes towards the poles, and then you have your trade winds, westerlies, easterlies can all be called prevailing winds. So because parts of the Earth move faster, that's going to have the wind kind of veering off and not going straight. Watch this video. They do a better job than me. Hadley cells. There we go. Hadley cells are giant cyclical air cells that move air, heat, and moisture vertically and from place to place in the atmosphere. This results when the heat from the sun evaporates ocean water, and then it's going to transfer that heat from the oceans to the atmosphere, especially near the equator where it's warmer because warm air rises. So energy transferred by convection, you have your warm, wet air rising. It's then going to cool and release all that moisture, and then it's going to sink back to the surface, and then it's going to warm and absorb moisture again and rise again. And I'll show you a nifty picture in the next slide. Air circulation patterns, prevailing winds, and configuration of those contents, what's in the winds, are going to help form these Hadley cells. So you have the sun, it's going to hit the Earth at different energy forces. So the equator gets the full force of the sun, and the poles are going to get a weaker version of the sun because it's not hitting it directly. It's kind of off to the side. So you have your northeast trades and your southeast trades. You have your westerlies happening. So here at the equator, it's the hottest. So warm air is going to rise and move towards the poles. As it does that, it's going to dump all of the water that was in the air. And that's where you get all these awesome tropical rainforests and tropical deciduous forest. Then that air is out of water and it's going to cool down and it's going to sink. And that's where you get your deserts in the planet. Then that air is going to once again kind of get warm and rise, dumping water. And that's where you get your temperate deciduous forests and grasslands. And then above that, where it's the dry area, you're going to get your cold deserts on both sides. And then at the very end, you have your polar caps. So this is kind of the how and the why this is happening. It all comes back to the sun and how it's hitting the earth. And all of these things happen because of how the sun's energy hits the earth. It's kind of cool. So now we have to talk about greenhouse gases and climate. And we will come back to this more later this year and next semester as well. So solar energy flows to the earth. The sun is shining on the earth. Some of it is reflected back into space, and some of it is absorbed by the greenhouse gases, which then warm the lower atmosphere, and we call this the greenhouse effect. This is good because otherwise it would be too cold on this planet to live. However, human activities such as production and burning of fossil fuels and clearing of crops are going to emit greenhouse gases into the atmosphere that can eventually change the climate. There's too much out there now. So wearing clothes, good, keeps you warm. But if you had like 4 sweaters on, you probably wouldn't be too comfortable and you'd be too hot. Kind of where the earth is getting to right now. It's a little too hot for comfort. Earth's surface features affect local climates as well. So when you have something like, say, a mountain, it can interrupt the flow of the winds and affect storms, and this is called the rain shadow effect, which I'll show you in a slide or two. The result is a semi-arid or arid climate, that means dry, on the leeward or eastern side of the mountain, and I'll show you a picture. And then we also can have cities that can create microclimates as well. So bricks, concrete, and asphalt are all going to absorb or hold heat. Recording on Fridays is not the best thing. Buildings will block wind flow, and then things like cars, heating and cooling systems are all going to release heat and pollutants and contribute to haze and smog. So different things can happen. So here's the rain shadow effect. So what happens is the winds pick up moisture from an ocean. They're going to go to where a mountain is, and then it can't go through the mountain, so it has to go up over the mountain. But as that air goes up, it's, to make itself as light as possible, going to dump its water. So you have all of the water on the one side of a mountain, and then on the leeward side of the mountain, the air is going to come back down. It's going to be much warmer because it was up and gets heated, and then it's going to have this rain shadow effect. So you have the rain on this side and very little on this side, hence rain shadow effect. And you have survived round 1 of the notes. So before I go, I just want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.